Okay, it's 1 o'clock. Welcome everyone to this next episode of our HDF Clinic. I checked our Google document where people sometimes leave questions before this meeting, and I didn't see any, but that doesn't mean there aren't any questions. So that's why I'm going to pause here and ask, is there someone in the audience who would like to ask a question about anything HDF5? Here's your first chance to speak up. Okay, that's fine. Nobody there, so we'll just do our usual, go through some announcements, see what's happening on the forum, and then there's some other material. Let's see, announcements. Yeah, Lori just uploaded the recording. There was a webinar last week in the HDF Performance Tuning series, and that's available now online. We have on May 14th, we have a very interesting webinar coming up about experiences working with HDF5 files in the cloud in Amazon Web Services in particular. I'm sure that's going to be very interesting. And then, as always, we will have our HDF Users Group meeting in the fall, and there is a call for paper and presentation or presentations out there. There's still another month almost to go to prepare that and submit something. So deadline for abstracts is June 1st. Keep that in mind. I'm going to pause again here. Any questions related to that or anything else? HDF5? No? Then okay, I'll just continue. There were some interesting questions on the forum. Again, this is a very subjective selection. I mean, there are a lot of questions about, and I don't know if I should bring them here because they are very sometimes specific to the environment. They speak to maybe how great or not so great the installers work that we provide with something like HDF View and so forth. But so there were a lot of those, some related to compilation and so forth. So I didn't bring them here, but you are welcome to leave a comment in that Google Doc, for example, if you would like to talk more about that. Although I think I would quickly reach the limits of how helpful I can be there, because I mean, I use the environment that I use more or less every day, so I don't have necessarily the experience with many other environments, but we can give it a try, or try to get you help, direct you to the places where you can find help. But the one that is kind of ongoing is this issue around copying objects, and I just I'm busy with project work at the moment, but I definitely want to get this straightened out. The link is here for your reference. There is a user, and he basically tries to copy a group or links, or we'll sort that out. But just from the perspective of the HDF5 API, there are sort of two fundamental two kinds of copy calls relevant to this. One is H5O copy. So the O, of course, stands for object. So we would expect that when we copy an object, we really copy the object, perhaps including the attributes that decorate that object, if the object contains references either to a committed data type or a reference in the sense of an HDF5 reference. We would expect that we could somehow control that aspect as part of the copy operation. And then on the other hand, there is this H5L copy link, which is very specific to links, that basically says, well, yeah, I'm in a group and I have a link that has implicitly the group that I'm in as its source, and a destination could be, depending on what kind of link it is, It could be another object, it could be just a symbolic link or an external link and so forth. And the goal of H5L copy, of course, is to really just copy that link. When you want to copy a link, you want to copy a link. You don't want to copy the object. So I think we need to help that user with that. But then, of course, in the case of H5O copy, if you look at the documentation, it's pretty extensive, and there are, of course, lots of corner cases and so forth, because the question is, well, yeah, an object can mean at least 3 different things at the moment. It could be a data set, it could be a committed data type, it could be a group. Groups are also included in those objects. But then the question is really, yeah, when you copy a data set or copy a committed data, what does that really mean? And that's where it kind of not exactly falls apart, but there are many corner cases. And if you have a setup where you have very specific ideas about what you want that copy operation to do or not to do, whether it has recursive behavior, let's say it's a group and you have other objects sort of downstream that are linked that you could visit recursively, then yeah, there are just so many different variants, and that's where it gets tricky. But I just asked that user, I mean, the user is helpful in the sense that he posted an H5 an HDF view screenshot with his post, but unfortunately it's easy to be fooled by what HDF view shows you, because especially when it comes to links, I mean, as we all know, it is possible that a link or a given object can be actually linked multiple times under different names from the same group or under the same name in different groups. And HDF view constructs this tree view form or control that you see typically on the left-hand side in HDF view. So, of course, if the underlying structure, the underlying link structure is not a tree, then what you see there in this tree view will be sort of a very distorted view of what's really in the file. And just to be 100% clear there, I just asked that user to send us the output from H5 dump, because at least H5 dump will not try to render this link structure as a tree view, but if there is a hard link, for example, to an object about which it has printed information already, it will just say, oh, this is a hard link, and it points to this other object and so forth. So I hope that then once we have that, we can make some headway. I'm sure we can work it out pretty quickly. It's just, you know, me being busy and then sort of back and forth, and sometimes it's not their fault, but in our documentation, the terminology between members of a group and we have created plenty of confusion there, and so it's just important to be clear and very specific about what people want to achieve, and then we help them. Okay, I'm going to pause here. I have something prepared that also is a great source of confusion. I've certainly made my fair share of mistakes in using it, but before I do that, I want to ask if there are any questions out there about HDF5 or anything related. Any questions? No? Okay. Then I'll continue. So in today's tips, tricks, and insights, I've picked something that looks fairly innocent, but that actually behaves in a way that you may not expect. And certainly when I use it for the first time, it usually works the first time because you basically use it in the way that it was probably intended, but then you start making assumptions and you start using it in ways that it actually wasn't intended. And then it gets tricky, and then it's important to understand what it does and how it behaves. And it's this thing called H5S all. So H5S all, technically speaking, it's just a macro. It's just a definition. I believe it's HIDT or 0. And but that doesn't really tell us anything. A typical use case for H5S all is, remember, when you either do an H5D read or H5D write, the sequence of arguments is typically, well, yeah, there is the data set from which you are reading or to which you are writing. Then it is the in-memory type. So when you're reading, the library, of course, knows what the type of the data set elements in the file is, but then it has to read these data set elements, and there could be a data type conversion along the way. So if your memory type is different from what's in the file, be it just because of endianness, but sometimes you go from 32-bit integers to 64-bit integers or something like that. So that's cool. That's the in-memory type. And then you have these two data space arguments. One is the in-memory data space, and the other is the in-file data space. And the purpose of these two is really to say, because, and that's the beauty, but also part of the complexity, is that the shape, meaning the dimensionality and extent and everything of source and destination, can be completely different. So let's say you have a one-dimensional array, a one-dimensional data set in the file, but you want to read something into a two-dimensional or higher dimensional array in memory. That's fine. It's equally fine the other way around. You're writing something from a two-dimensional array, either the entire two-dimensional array or a subset of it, into a one-dimensional array or into some other four-dimensional array or something. It doesn't really matter. And then you use these data spaces and typically define selections on them, and we'll see that in a moment: hyperslab selection, point selection, and so forth. But then in the simplest case, you might say, well, in sort of the simplest case, probably where the shape of the source and destination data spaces, regardless if it's read or write, is the same, the question would be kind of, well, why bother? Why do I have to define anything? I can just say, it's all good. It's all the same. Just, it's the same. It's a one-dimensional array. It has 50 elements in memory, and my data set in the file has 50 elements. It's just H5S all, H5S all. So that's when I used H5S all for the first time many years ago. I just had H5S all, and everything was good. Writing that data, reading that data, it all worked beautifully. And then you probably one day sort of ask yourself, well, what is this H5S all thing? Really, it gets interesting when only one of them. So either the in-memory data space would be H5S all, or the in-file data space would be H5S all. What does that really mean? Because I can have a selection defined on this F space here. And what does that really mean? There's no selection on here. So what does the library do? How does the library know what this destination really is? And this is where the term H5S all as the sort of name of a macro also becomes a little confusing, because let's say my selection here, and we will see an example in a moment. Let's say I have 5 elements selected in this space here. Does that mean that H5S all is also just 5 elements? But then it could be in the file space, for example, let's assume it's not just a contiguous region of 5 elements, let's assume it's sort of a strided pattern, like I have really 10 elements, but I'm skipping every other element. And that would still be 5 elements, but then what would H5S all again mean? Would it be still 5 contiguous elements? So is the HDF5 library for me automatically going to sort of contract or compact that selection? So that's where it gets a little iffy. And what typically happens, what happened to me at the time, the first thing is, yeah, you will get some kind of error. If you have the error stack enabled, you will see error messages, or otherwise you will just get a sec fault or something like that. And then you will ask yourself, well, what's going on here? Okay, so let's maybe introduce this example a little more closely, but this is just sort of where we are coming from. H5S all is this thing that it looks like it can save us some time declaring an extra data space in the file and or in memory. And it's safest if, yeah, the H5S all goes into both arguments for H5D read and H5D write. And if not, we have to be careful. And I will try to explain why and how. Okay, so this is an example that is actually taken from the sort of new documentation that we are preparing based on Doxygen, and it's online. And what we are doing here is basically we are assuming I have an HDF5 file, and in that HDF5 file, I'm just using these Greek letters here to indicate that you can use arbitrary Unicode strings as your paths in HDF5, and that's why I'm using Greek letters here. So I'm using a UTF-8 encoded path name, and there is a data set already in that HDF5 file, and it turns out it's 10 elements. It's one-dimensional. It has 10 elements, and that exists. So I'm not showing you the code here to create the data set and so forth. In this case, it exists already. But what I wanted to show you is, so assuming I have an HDF5 file, I have an existing one-dimensional data set with 10 elements. Now I have, for some reason, I have a two-dimensional 6x2, so it's not 10, it's 6x2, two-dimensional array that has 6 rows, 2 columns that just looks like this. So I have -1, 1 for the first row, -2, 2 for the second row, -3, 3, and so forth. So I got 6 rows, and always the integer, and the negative, and then the integer itself. And I want to write, obviously, since it's 6x2, I said 6x2 is 12, obviously. So I have 10 elements. I have capacity, if you wish, for 10 elements in the file. So it definitely wouldn't work to write all 12 elements into this 10-element data set. But what we will do, and we do that down here, we make a hyperslab selection where we basically pick out the, we always here in each row, we have sort of a negative column and a positive column. We'll pick out the positive column except in the last row. So we will not write that 6, but otherwise we will pick out 1, 2, 3, 4, and 5 and write those into our one-dimensional data set. And the question is, well, along the way, we would like to use H5S all, and then the question is, well, what happens with that? Okay, so I'm just showing here the sort of the boilerplate code. We open the file, we open the data set, we get the data space. So here, at this point, we would see, aha, if we parsed it out, we would see, okay, this is a one-dimensional data space, and it has 10 elements. But here we, in a way, I didn't include that code that would do the parsing, where I would say, okay, what's the rank of the data space and what's the extent and so forth. So I left that out. But then, assuming I had that knowledge, I'm going to define a hyperslab and a regular hyperslab, and I'm going to pick in that 10 length array, so to speak, every other element. So if you remember, when you call H5S select hyperslab, there is sort of this pattern where, okay, the first argument is the handle to the data space that we are dealing with. The next argument is the operation that I want to perform on that file space. And then it's basically this start, stride, count, block pattern. And in this case, since it's a one-dimensional array, the start, stride, count, and block, they are one-dimensional arrays, or in this case, yeah, I can just define them sort of as stack variables. And I want to select 5 elements, and I want to pick the alt positions. That's why my start is 1. So I'm not starting at 0, but I'm starting at 1. The stride is going to be 2. So I'm going to, instead of having a contiguous, selecting a contiguous hyperslab, I'm going to skip every other element. And I'm doing that 5 times. And the block size is 1 in this case. So it's always 1 element. But in the if you look up the documentation for H5S select hyperslab, the way instead of adding another H5 another H size T bracket 1, I can just be lazy and pass in null, and the library will be happy with that. Okay, so this is a selection on a one-dimensional data space in the file, where I've sort of skipped the first element, selected the next one, skipped so in C notation, depending on if you're a C or Fortran person. So we have skipped 0, selected 1, skipped 2, selected 3, skipped 4, selected 5, and so forth. So 5 of them. And so that's our selection in the file space. And then what we do is, remember, when we do this H5D write, the order is that the first data space is the selection in memory, and the second data space is the selection in the file. Now, curiously, I've thrown in H5S all here, and the question is, what happens now? Because, as I just said, in F space, I have this selection where I skip the first element, select the next one, and so forth, select every other one 5 times. What does that mean for H5 or for H5S all? And by the way, this is a write call, so the file space is the destination. The source is H5S all, and we'll figure out in a moment what this is. But I'm drawing my elements from this 2-dimensional array, new elements. Maybe I can scroll this a little bit so we see both. So just as a reminder, my new elements array was this 6 rows, 2 columns array. And that's from where I'm drawing my values. So what happens is, actually, since, if you wish, I wish there was a better name for this, or at least I can think of a good name. But in this case, what happens is, in a way, the selection that you make on the file space is sort of shadowed or mirrored onto this thing here. So what this tells the HDF5 library is pretty much, well, whatever is in memory space, sort of use the same sequencing, the sequencing in the sense of where you start, how you stride it, how many you write, and then the block size, which in this case is just 1. But this is what this means. So if I put H5S all here and put F space here, the library will assume, well, first of all, that in memory, I have at least as many elements as I'm selecting here. That's 1, but that's not sufficient. So it will assume that there are at least 5 elements present in memory in this array. But to make matters actually, and that's where the tricky bit comes in, it will apply the same pattern in memory that it's applying in the file. Meaning, okay, we said we are going to skip the first element. So maybe I'm going to hit the pause button here and just say, we all know, of course, that this is just syntactic sugar for that what we sell to C or make to C look like a two-dimensional array. C doesn't really have a concept of dimensionality. It's just a contiguous one-dimensional array in which is laid out in sort of row-wise fashion, meaning this is the first element in this abstract one-dimensional array in this address space. This is the first element, this is the second element, this is the third element, the fourth element, and so forth. So this is for C, this is a one-dimensional array that has 12 elements. Now, coming back here, so what I said is the pattern that I have selected in F space will be kind of mirrored or shadowed onto whatever the shape of this is. So that means two things. Number one, it means we need actually at least 5 elements, but that's not sufficient because, as I said, the HDF5 library will follow the same pattern, which is it will not select the first 5 elements here, -1, 1, -2 to -3. No, as we said here, we have a start of 1, so we are going to skip the -1. We are going to select the next one. We are going to skip the next one, select the next one, skip this one, select this one, and so forth. You get the idea. So effectively, we are selecting in memory 1, 2, 3, 4, 5. And what that would mean is, yeah, if I had an array, if new elements had only anything less than 10 elements, if it had only 9 or 8, or you would get a segmentation fault because the library in this case would be attempting to read beyond the bounds of this array. And so this is what happens is with this, call it the mirror effect. And of course, the same applies if the order were reversed, in the sense that I would specify a in-memory selection and would use H5S all for the selection in the file. It would sort of superimpose or mirror that pattern that I defined in memory onto what's going on in the data space. And yeah, you are responsible for, you have to make sure that that pattern can really be superimposed correctly without reading out of bounds and so forth. So this is pretty much this is all that there is to it, really. If both are H5S all, that's the safe case, and that's probably the first example that we all write. But then there comes this awkward moment, at least it came for me sooner than later. There comes this awkward moment where you think, oh, doesn't H5S all just mean, oh yeah, just take that whole thing and so forth? No, that's not what it means, unfortunately. And it is tempting, given the naming, to believe that. But unfortunately, that is not the case. And that is, in a way, that, yeah, once you get the hang of that it's really when you specify ones, that gets sort of projected or superimposed onto the other. Then you are good, and then you will make it work for you, if you can make it work. Do things work out like that very frequently? Not really. I mean, I personally don't use it very much because there's just very little occasion. It's certainly a savings if you can arrange things with one selection so that things just nicely align with the other selection. Then you can say, well, why define another data space and so forth. But that really doesn't happen too often. Okay, that was it for our tip and trick, and I'm afraid we are close to out of time. Let me just tell you something what's coming up. Our very active community member, Stephen Varga, volunteered to give us a very interesting sort of short presentation on sort of the performance implications for using fixed versus variable length strings. And I really look forward to that, and so should you. So you really don't want to miss that one. There's a good chance that it will be next week, but if not, then the following week. The good news is you always have the recording on YouTube, and yeah, I invite you to go there, look at previous episodes, and ask questions next time. Thank you.